Hi guys, this is lesson 1.6 and today we'll be talking about continuity. When we say a graph is continuous, we mean that a graph goes without any breaks or jumps or gaps. The following situation displays the idea of continuity. The first situation is that the graph is continuous for all values of the domain. We have a graph in the middle of the slide, and this is usually true for polynomials, because the graph of polynomials goes without breaks or jumps or gaps. The next situation is continuity at a point. The function f of x is continuous at x equals to a if f(a) is defined and if the limit as x approaches a of f of x equals to f of a. If this equation does not hold, then we say f of x is discontinuous at x equals to a. Next, we have discontinuity at a point. First, we have point discontinuity. You can think of it as you're taking this point on the graph, it's just one point, and then you're sliding it somewhere else in the y-axis. So at this point in the graph, x equals to x0 will be discontinuous. The second one is jump discontinuity, in which the graph sort of takes a jump at x equals to x0. The last one is infinite discontinuity. One example is y equals to 1 over x, in which the function goes arbitrarily large in either direction or arbitrarily small. Now let's take a look at example 1 from the learning resources. We have f of x equals to x squared minus 3 for x is less or equal to -1 and x minus 1 if x is bigger than -1. Question A asks us to determine the limit as x approaches -1 of f of x. The solution for this is quite simple. We want x is close to -1, therefore we can take the first equation because x is less or equal to -1. So what we do next is we plug -1 into this equation, so that would give us 1 minus 3. And the final answer would be -2. Question B actually asks the same thing. Determine f of -1. So once again, we plug -1 into this first equation because -1 is part of the domain in the first function. So once again we get -2. Question C asks, is f continuous at x equals -1, and explain. To do this, we have to use the solution that we did for question A and question B. And we see since the answer is both -2, therefore f of x is continuous at x equals -1, since f of -1 equals the limit as x approaches -1 of f of x. Now let's take a look at example 2 from the learning resources. Where are the function discontinuous? So we have f of x equals to x squared plus 1 if x is less than 0. F of x equals to 0 if x equals to 0, and f of x equals to x squared minus 1 if x is bigger than 0. When x is less than 0, we have a polynomial of x squared plus 1. And when x is bigger than 0, we also have a polynomial of x squared minus 1. We know that for a polynomial, it is continuous because there are no breaks or gaps or jumps. So we say f is continuous when x does not equal to 0. So the only possibility for discontinuity is when x is equal to 0. Therefore, the limit as x approaches 0 of f of x have to be examined. What we do is we take the limit from the left side of 0, and then we take the limit from the right side, and we see if it is equal. If it is, then it is continuous. If it's not, then it's discontinuous. So when we take it from the left side, we have limit as x approaches 0 of the first function, because as for x is less than 0. So we plug 0 in and we get positive 1. When we approach 0 from the right side, we have to use the second equation because x right now is bigger than 0. And at the end we'll get -1. Since the left and right limits are different, the limit as x approaches 0 of f of x does not exist. Therefore, the function is discontinuous at 0. And that's the end of this lecture. Thank you guys for watching, and I'll see you guys